Okay, we are continuing on with normal distributions today. Let's have a look. A machine produces metal bolts. The lengths of these bolts have a normal distribution with a mean of 19.8 and a standard deviation of 0.3. If a bolt is selected at random from the machine, find the probability that will have a length between 19.7 and 20. Step 1. What do we do first, Chris? Great, that's actually going to be step 2. Diagram is definitely going to be needed, but before we get to that diagram, what should we do? What should we communicate to our marker? That we know it's normally distributed. Good. So we should probably even define what the variable is. If I'm going to choose x, we need to say let x equal, what is x going to be? What is x? What is the random variable we're looking at? Anybody? Anybody? No Sophie today. You're going to have to step up. What is x? Okay, nice. It's the length of the bolt. No, that's excellent. So x is distributed normally. How do I say that it's normally distributed? Good, capital N. Open brackets. The first variable in the brackets is mu. What does mu represent? The mean. What's the mean? 19.8, and it is the average. Good. The standard deviation. Does the standard deviation go in the next bit? No. What? Standard deviation squared, also known as the variance. Now, Chris, we draw our diagram. So we draw a little normal distribution. 19.8 is the mean, so we draw that peak in. And we want to show the area between 19.7, which is a little bit to the left of 19.8, up to 20, a little bit to the right. And we shade that area in. And if you don't feel confident doing that, remember your calculator can do it for you. Thanks again to Josh for that discovery. So we go into, what mode do I need? Stat mode, correct. Then we go distribution, then we say it's a normal distribution, and we say NCD because I'm looking at the cumulative distribution. 19.7 up to 20. Standard deviation is, what is it, 0.3? 19.8, final answer. So there's our sketch, beautiful, looks pretty much like mine. Probability is 0.378. Good, 4 decimal places. So you say probability 19.7 is less than or equal to x, less than or equal to 20 is 0. I forgot it. Go, Nicola. Awesome. Hey, you got that? Wow, you're superstars. Okay. We're going to go one step further today. Oh, how dare I try to teach you. Okay. The time taken by students to complete a puzzle is normally distributed with a mean of 28.3 minutes and a standard deviation of 3.6. So, quick, define your variable. Go, go, go. So easy, good, do it. Okay, Alex, what do you think we should define it as? Have a read of the question. What is the variable that has been normally distributed? Well done, and good finding a friend. Time taken to complete a puzzle. All right, x is distributed normally, whoops, forgot my n there, normally mean 28.3, comma, sigma squared. You do not need to bother finding out what 3.6 squared is, just leave it like that, that's fine. Okay, can we calculate the probability that a randomly selected student takes less than 30 minutes to complete the puzzle? At least, that's better. Let's go more than. More than or equal to Now, remembering that for continuous random variables, the probability that x equals 30 is going to be what? 0. So the context of this question, please make sure you've got greater than or equal to, but the reality is that it's going to be the same thing as just greater than, because the probability of it being equal to 30 is 0. But for this question, it says at least, which is greater than or equal to. So go in and adjust your stat mode accordingly. Part A, nothing new. What is my lower bound going to be? 30. What is my upper bound? Maddie, my upper bound, what do you reckon? 20,000? Fine. 1,000? Also fine. I don't know if your calculator will like that, but you can try it. You just want it to be ridiculously large because that normal distribution can have that really rare outlier on either end. So you just make it really large to make sure that it is covering. All right, so we get 0.3184. Now, I have been a little bit slack here. Why have I been slack? Oh, naughty. Mrs. Tucker, so lazy. Okay, that's what I'm going to say when I look at your exams if there's no diagram. 30. And you can use your diagram to help you figure out if your answer is reasonable. If I got an answer of 0.8 and my diagram looks like that, I would be thinking something is wrong. Looking at that diagram, you should know it's going to be less than what? It has to be less than what? Look at the diagram. Half, because we know it's symmetrical and there's half on one side, half on the other. Okay, here's the slightly newer bit today. It says, out of 10 randomly selected students, at most, half of them took at least 30 minutes to complete the puzzle. So we have a fixed number of trials, 10 students. We have a probability of success for those students, 0.3184. What type of distribution have we now gone to? Binomial. We have now gone to a binomial. So let's pick a new variable. What letter do we want to go with? So random, but okay, C. Let's see. Sorry, I'm not going to use P because we're doing probability. Let's see B, the number of students. That took at least 30 minutes. If C is distributed binomially, what do we say? It's distributed, what goes next? B. Okay, in our binomial distribution, what information do we require? N and P, awesome. How many trials were there? 10. And the probability of success, we've said, is 0.3184. Oh, you see what I did there? Yeah, pretty cool. So now we've got a binomial distribution, and the question says, out of 10, what's the probability that at most half took 30 minutes? So what are we actually solving for? The probability that C is at most half. What does that mean? Maximum of 5. Why 5? Because that's half of. Yeah. Now, in this case, does that equal sign underneath the inequality matter? It does. Good, because for binomial, we are actually going to be solving C equals 0 plus probability that C equals 1 plus all the way up to probability that C equals 5. So it really does matter. All right, so go back to your calculator now. And we want to change out of this distribution and we want to go into binomial distribution. Now, should I use BPD, BCD, or inverse binomial? Hands up for BPD, F1. Hands up for F2. Oh, well done. Why? Almost. It is not a continuous variable, guys. This is now a discrete random variable. Why are we using cumulative distribution, though, instead of the, back for round 2? I like it. Good. There's a less than or equal to. We are given a range of answers. It's not just saying find the probability that C equals 5. It's find the probability that C is up to 5. So we go CD. Our lower is, what's the lower now? What's the lowest option we could have? 0. We could have none of the students do it in 30 minutes, up to 5 students doing it in 30 minutes. There are going to be 10 trials, and a probability of success is 0.3184. And then we execute it 0.9377. Did we get that on our calculator? Can we see how we changed A by, what did we have? A normally distributed continuous random variable into a binomially distributed discrete random variable. Slightly different switch. All right, you're 10 minutes down. Let's go for 10 more minutes. Okay. All right. I want to teach you a little bit more about Z-scores. What do you remember about Z-scores? I briefly touched on it yesterday. Can you draw a Z-score diagram for me? It's a normally distributed variable. Can you draw the diagram for Z-scores, please? All right, your diagram. What should be the minimum, the maximum? Where does that maximum occur? What's the mean of the Z-score? Yes, say it with confidence. 0. Less confidence. 0. There is a 1 in there, Vedant. What's the 1 for? Area is also 1, but Z-scores are involved with a 1 for another reason. What's the 1 to do with the Z-score? Standard deviation. Good. So the Z-score is a variable that's distributed normally with a mean of 0 and a standard deviation of 1. There we go. So let's get that percentage recap from last lesson. What percentage, oh, it's exciting. What percentage of results are going to lie between -1 and 1? 68. Excellent, Oscar. What about between -2 and 2? 95. Good. And between -3 and 3? 99.7. Excellent job. Okay. Now, a Z-score. We use Z-scores to help us compare different scenarios. So let me show you this question. This is a bit of the underlying principle of how your ATAR results get calculated in the background. Z-scores allow comparison between things that normally are tricky to compare, like how you did in methods versus how you did in chemistry. So Kelly scored 73% in history, where the mean was 68% and the standard deviation was 10.2%. In maths, she scored 66%, where the class mean was 62% and the standard deviation was 6.8. In which subject did Kelly perform better compared with the rest of her class? This is exactly what happens for your calculations. It used to be a lot more the case when we did OP. Basically, when you read those scores right now, which subject did she do better in on raw scores? History, she got 73%, but maths, she only got 66%. So A z-score, how do we actually calculate it? This is the formula that you need to know. Z, the z-score equals x minus mu, all divided by sigma. So what we are going to do is we are going to get Kelly's z-score for history, and we're going to get Kelly's z-score for maths, and then they will be in the same scale, the same unit of measurement, and so we'll be able to compare them. At the moment, one of them's a history result, one of them's a math result. They're not very comparable, so we need to make them the same. Now, what's this sigma and the mu? We should know them. Sigma and mu stand for mean and standard deviation. Awesome. Okay, so for history, if you want to have a crack, you go ahead now. But for history, her z-score is going to be her score. That's what the x stands for. So what did she score? 73%, good. Minus mu, what's mu? 68%, that was the average. All divided by the standard deviation, which was 10.2. So chuck that in your calculator, please, and let me know what you get. Thank you. 0.490. Now, can you please find what her z-score result? Actually, let's interpret that really quick. A z-score of 0.49. Think about it. Here we go. We've got -1 there, 1 there, 2 there, -3 there. 0.49. Is she above or below average? Above average? Is she well above average? No, she's here, which is where roughly there's going to be 68% of the population is lying one side, standard deviation either side of the mean. So she's not really that far above average for history. Okay, have a look at maths, please. Go find her z-score for maths using that formula. Can do. It's probability. You definitely want to do to 4 decimal places. Z-scores, I would say 2 or 3 is fine. All right, Emma, what was her math mark? Yeah, lovely, 66. And what gets subtracted from that? 62, and it all gets divided by 6.8. Excellent. And her z-score from math then, Jamie, what'd you get? Oh, Alex, what'd you get? 0.58. 588? You want to get 588? Yeah. Okay. So again, maths, she's above the mean. Is she well above the mean? No. But which subject, if we look at her z-scores, compared to the rest of her class, which subject did she do better in? Why? Because it's a higher z-score. She's further above the mean for maths. Excellent. Okay. This last one, you should be able to do this on your calculator, but I want diagrams, so just have a go with this. Go for 2-3 minutes, and then yeah, I think we'll finish. Make sure you include your diagrams, please. answer for A done. Come on, Ish. Let's go. This is not tricky. This is perfect Friday period 7 maths. 4 decimal places for probability, please. All right, have a look at your neighbor's work. Make sure they've got some diagrams going on. Okay, what did we get for A? Euro, what did you get for A? Ah! 0.4077, right? Ben, what'd you get for B? 0.9332, excellent. So you should have something like this for each of those. I went 3 decimal places, whoops, for A, so you should have 4. And for C, Oscar, what'd you get for C? Ashan, what did you get for C? Okay. 0.79. Have a think about it. The probability that it's greater than 0.84, if you think about your Z score, we're greater than, yeah, you might have gone the wrong way, so go the other way. Or subtract your answer from 1. Race him, Oscar, race him. Pressure's on, Ish. Yep, 0.2005. Okay, and if you got something like 0.7 for that, you would know, your diagram would help you know that you've made a mistake somewhere in there.